Hey guys, today we're going to start our next section, which is still talking about derivatives. Okay, so we're going to start off by graphing or sketching what the graph of the derivative is going to be based off of what the graph of the original function will be. And then we're going to talk about another way, which is going to be a great way of finding the derivative, which you guys will like so much better than the last way. It's so much shorter. All right, but first off, all right, just take a look at these three different notations. All right. Um, See this little apostrophe? You guys saw this middle one before, right? This means you want to find the derivative of y. So when you see that there, it just means find the derivative of y. This would just mean find the derivative of f of x. And also, if you see dy over dx, that also means the derivative. All of these mean to find the derivative. Okay. Now, so what we want to do in this example is we want to be able to graph what the graph of the derivative is going to look like based off of the original function. All right, now remember the definition of a derivative is the slope of the tangent line. So if we can figure out what the tangent line of this is, then we can figure out what the slope of that line is. Okay, so the y values basically, so the y values, sorry about this writing. All right, the y values of the derivative, which I'm just going to write as f a little apostrophe, that means the derivative. All right, remember, they represent the slope of the tangent lines of f. That's where it should be tangent. All right, the tangent lines of f. Okay, so what we want to do, if you remember, with a straight line, the derivative of a straight line is the line itself. Okay, so this has just one tangent line. Well, what we're going to do is, what is the slope of this line? Well, let's see, rise over one. If I go this point, I go up one to the left one. So what is my slope? The slope of the tangent line is -1, which means the derivative is -1. So the y values of the derivative are going to represent the slopes of the tangent line of f. Well, there's only one tangent line, there's only one slope, it's -1. Well, how do I write all y's with -1? You draw a horizontal line going through -1. All right, this is y equals -1. All right, point down there, you draw a point through it. It has just one horizontal line because there's only one tangent line. If there was multiple tangent lines, we have multiple horizontal. So whenever we're going to have a straight overall function, our derivative graph is going to be a horizontal line. All right, so if we look at 2, hopefully what you notice is you have 1, 2, 3 different parts to this graph. All right, 3 different straight lines. So what's going to end up happening is we're going to have 3 horizontal lines over here. All right, now for this first blue one, all right, this first blue one, what's the slope of this? It starts here at -1. It goes up 1, 2, and to the right 1. So that means the slope of this line is 2. So we are going to draw a horizontal line for 2. However, what are the x values that it's happening at? It's happening from -2, starts here, and ends at 0. So from -2 to 0, we're going to draw a horizontal line. Now, we are going to put open circles. Why am I putting open circles? Well, I am now allowed to have what at a endpoint? A tangent. Also, this is a corner. We're not going to have a tangent there. That's a corner. That's an endpoint. So all of these are going to be open circles. All right. So for this one, all right, we have a horizontal line. What's the slope of a horizontal line? It's 0. So where is it going from? 0 to 2. So from 0 to 2, I am going to draw a horizontal line with open circles. And then finally, I have this. What's the slope of this line? The slope of this line is -1, right? Down 1 to the right 1, that's -1. So where's it going from? That's going between 2 and 3. So between 2 and 3 at -1, going to draw open circle, and there you go. So there is the graph of my derivative. All right. So whenever you have a straight line, if there's just one line here, there's just one horizontal line going forever. If I have a bunch of straight lines, there's going to be, that's how many horizontal lines there are going to be. You figure out the reason this was from -2 to 0 is because this goes from -2 to 0. This blue one was from 0 to 2. That's why this went from 0 to 2. All right. Now that's what's for straight lines. All right. It's a little different if we have curved lines. Okay. So what we want to do with curved lines first, all right, we want to locate, we're not going to be able to get as exact for these. All right. We are going to locate horizontal tangents. Where would there be horizontal tangents? Right. And okay. All right, where is there going to be horizontal tangents? Well, horizontal tangents are going to happen at peaks and valleys, meaning at the top of curves or at the bottom of curves. So right here, I have a horizontal tangent at what x value? At 0. Okay, so I'm going to put a point at 0. Now, I don't know what the exact slope of all of these things over here, right? But if I were to draw, right, if I draw these, what kind of slopes do they all have? Is it all positive or negative? Well, it's going to be positive. What represents a positive slope? The y value that's positive. So wherever this is, like, if you look, wherever it's increasing like this, that's where you have positive slopes. If I were to draw on the right side here, draw a bunch of tangents, notice they have all negative. That's because this is decreasing. So when it's increasing, is a positive slope, decreasing a negative slope. So all you have to do is left of 0, it was increasing, which means it's positive. Just draw some curve pointing up. And to the right, it was negative. Just draw some curve pointing down. All right. So something like that. That means less than 0. All right. All of the slopes are positive. Greater than 0, all the slopes of the tangent are negative. That's basically what it means. All right, so we're going to do the same thing for 4. First thing we do, find the horizontal tangent. So our horizontal tangents happen at -1 and +1, right? -1 and +1. All right, now to the left of -1, that's this part of the graph. Is this increasing or decreasing? It's increasing, which means I have a curve going up. Then between -1 and 1, it's going down, which means I go below. And then for the last part, it is now increasing again. So I am going above. And that graph looks fine. Now, would it be nice to draw a nice little parabola? Sure, but this will do. All right. This tells me the slopes of the derivative to the left of -1 is positive, in between -1 and 1, it's negative, and greater than 1, it is positive. All right. Take a second and see if you can figure out what you think this would be. First thing I want you to figure out is where are there going to be the points on the x-axis here. All right, go ahead and try that now. All right, so what you should have seen is that horizontal tangent there, horizontal tangent there, horizontal tangent there. Meaning that's -2, there's a point on the x-axis. 0, there's a point on the x-axis. +2, there's a point on the x-axis. All right, now you got to figure out, is the curve above? Is it below? Whatever it is. So to be -2, it's going down, which means that's down. Then we start going up between -2 and 0. So then it goes up. Then it goes back down. And then it goes back up again. So it looks something like that. All right. So a nice, smooth curve like that. I mean, it doesn't have to be a perfect drawing. All right. So recap, you find the horizontal tangents, the peaks and the valleys. That's where you get these points from, the -2, the 0, and the 2, because that's where the horizontal tangents were, the peaks and the valleys. Then you look, see wherever it's decreasing, that is below for the derivative. Wherever it's increasing, that is above. All right. Now, rules of differentiation. All right. And you'll like this much better than the definition of derivative. I can promise you that. All right, notations of the derivative. Talked about that already. All right, that's if you can have y, a little apostrophe, you can have f of something like that, or you can have dy over dx. Okay, now some formulas here. First thing here, this is saying what's the derivative of a constant. All right, the derivative of a constant. So like for instance, if I wanted to know what the derivative of y equals 5 was, if I wanted to know 5, well, the graph y equals 5, all right, it looks like that. Well, what's the tangent line to that? The tangent line is this line. And what's the slope of any horizontal line? It's 0. So the derivative of any constant is always 0. The derivative of 10, 0. The derivative of 99, 0. The derivative of 1 million, 0. The derivative of 1/5, 0. If it doesn't have a variable in it, the derivative is always 0. All right. Now, the power rule. All right. You guys will love this. All right. The power rule tells us how to find the derivative without having to go through and doing the f of x plus delta x minus f of x all over delta x. All right. This is a much quicker, save you all the time in the world. All right. And you're probably like, why didn't I show you this first? Well, it's just the way life works. All right. And now you can see exactly where it came from with all the limit stuff. But now, from now on, when you're finding the derivative, you can just use this nice, easy power rule, and we'll learn other rules as well. But what the power rule says is this. All right. If I have x raised to some power, x to the n, you move the exponent out to the front. That's why, see how the n is the exponent and now moves out to the front. Write x again, and then the new exponent is going to be n minus 1. So you're going to take 1 away. All right, so what's that mean? X cubed. The exponent 3 is going to come to the front. I'm going to keep x there, and then I'm going to go 3 minus 2, 3 minus 1, which is 2. And the answer is 3x squared. So the derivative of x cubed is 3x squared. You can go back and look at all the examples we did, definition of derivative, and anything with the cube that you had to do all that crazy stuff with, now you can just do something like this. All right, so what would x to the 11th be? Well, x to the 11th would be move the exponent out front. 11, x, take 1 away from the exponent, becomes 10. 11x to the 10th would be that one. All right, now, when we go to something like C, where you have a radical, all right, now, you're like, well, where's my exponent? Well, I can rewrite this, all right? I can rewrite the cube root of x as x to the 1/3. So now, same thing, move the exponent out front, keep the x, and now I take 1 away from the exponent. And what's 1/3 minus 1? Well, 1/3 minus 1 is negative 2/3. So I get negative 2/3. Now the problem is I am not allowed to have a negative exponent. All right. So what we're going to do is to make a exponent that's negative positive, you just move it to the bottom. So this is going to be 1/3x to the 2/3. So it's a 3. All right. This one. We have 1/x to the 4th. I can rewrite this as x to the -4th. All right. So now move that out front. -4x. What is -4 minus 1? It's -5. I'm not allowed to have a negative exponent. So I move the x to the -5th to the bottom and make it positive. So -4 over x to the 5th is my derivative. All right. So the power rule says that you move the exponent out front, keep the variable, and then you take 1 away from the exponent. And we'll do tons of practice with this. All right. Constant multiplier. All right. Constant multiplier just means that if you have something out front, like notice here, there was nothing in front of the x's. Here, if we have 3, no big deal. We'd still do the same rule. Move the 2 out in front, but you just multiply. 2 times 3 is 6. X to the, 2 minus 1 is 1. So the answer, the derivative of 3x squared is just 6x. All right. Go ahead and try B. See if you can figure out what B is. All right. For B, you move 6 out front, but there's a half. 6 times a half is 3. X, take 1 away from 6, is 5. 3x to the 5th is the answer. All right. All right. Here, we have to move the x to the 4th up top. So it's 1/5 x to the negative fourth. So I move the negative 4, but there's already a 1/5. Negative 4 times 1/5 is negative 4/5 x to the negative fifth, but I have to move that to the bottom, so it's negative 4 over x to the fifth power. And there's my answer. All right. All right. Now, sum and difference. Sum and difference just means we have in this problem 1, 2, 3, 4 different terms. All right. All these other ones above were just one term. No big deal. All right. What you were going to do is you were just going to find the derivative of this one individually, the derivative of this one individually, and the derivative of this one and that one. So go ahead and then put them all together, and that's your answer. So go ahead and try to do each of those. All right. What you should have got, 5x cubed is 15x squared. 2x squared is 4x because 2 times 2 is 4. You take one away. 5x is just 5. What's the derivative of a constant? It's 0. So you don't write anything. You don't have to write plus 0. So 15x squared minus 4x plus 5. The reason this is just 5 is because this is 5 to the first. 1 times 5 is 5. All right. But you take a 1 away from 1 and you get 0. So anytime it's like the derivative of 20x, it's just 20. The derivative of 100x is 100. The derivative of a million x is just a million. The x just disappears. All right. So there's the derivative of that one. All right. For B, go ahead and try B on your own. All right, so for this one, 4 times 4, 16, x cubed, plus 2 times a half is 1, plus x to the first, that's it. And then plus 8x is just 8, and 1/3 is just 0. So it's 16 x cubed plus x plus 8. All right. Now, last one, all right? These are, this one's a little bit trickier, all right? Because you have the 4th root of x. So this means x to the 1/4 over 3. So I got to put the 1/4 out front, but 1/4, the 3 on the bottom means 1/4 times a third, which is really 1/12. So x over 12 to the negative 3/4, which is 1 over 12x to the 3/4. Whoops, I didn't put my x in there, sorry. 12x. To make it positive, you have to move it to the bottom. So it's 1 over 12x to the 3/4. All right, so that one's done. Now, this one here, I have to rewrite it as 5x to the negative third. And there's already negative out front. So negative 3 times negative 5 is positive 15. And then it's x to the negative 4th. But I move that to the bottom, and I get plus 15 over x to the 4th. All right. Now for the next one, it's 2 times 2/3, right? 2 times 2/3 is 4/3 x. All right. All right, because we take one away and get 4/3 x. And then the 7x is just plus 7. All right, so I get 1 over 12x to the 3/4 plus 15 over x to the 4th plus 4/3 x plus 7. All right, so that right there is a much easier way of finding it. And like I said, I'm going to stop here for now. And that's going to be, we're going to practice using these rules, all right, throughout the next week. And we'll actually learn a little something else. We'll do some trig stuff, and we'll learn some product and quotient rules as well. But for this, right now, we're just going to stop here, and hope you guys have a great weekend.